Okay, here we have a limit, the limit as x approaches 6 of 17 over x minus 6 quantity squared. Because we're asked to find the limit as x approaches 6, we need to check the limit. We need to check the limit as x approaches 6 from the right, and make sure that those two values are equal. X minus 6 in the denominator means that we're going to have a vertical asymptote at x equals 6. So there's our vertical asymptote at x equals 6. We're going to put a value in to the left of 6 and find the limit from the left. So when I do that, I get 17 over, I'm going to put in 5.9. So 5.9 minus 6, and then quantity squared. I'm going to move my work over here. I don't want to mess up that beautiful graph that we got going on. 17 over, that's going to be negative 1/10 squared. And I like fractions a little bit better than I like decimals, actually a lot better. So you'll see me change things to fractions all the time. It avoids me having to pick up a calculator. 17 divided by negative 1/10 squared. Well, negative 1/10 squared is positive 1 over 100. The negative times the negative becomes a positive, and I have 1 over 100. And then 17 divided by 1 over 100 is the same thing as 17 times 100. So pretty big positive number. So we can say that what's happening as we get closer and closer to x equals 6 from the left is something like that. Okay, don't know what else is happening to the left. All I really care about is what's happening in this section right here on the left-hand side of the asymptote. Now I'm going to check on the right-hand side of the asymptote and what's happening on that side. Okay, so if I want to check from the right-hand side, I'm going to do this in red. Actually, I'm going to put positive infinity right here. So positive infinity, and I'm hoping that the right-hand side is going to equal the same exact thing, positive infinity, because if they are both approaching positive infinity, then we can say that that's exactly what the limit is as x approaches 6, because it's doing the same thing on the left as it is on the right. Okay, so on the right-hand side, let's change my color here, 17 over, on the right-hand side, I'm going to pick maybe 6.1. So I'll have 6.1 minus 6 quantity squared, and that's 17 over 6.1 minus 6 is 1/10, and 1/10 squared is 1/100th, and dividing by 1 over 100 is the same thing as multiplying by 100. So we know that, and it's positive, so we know that what's happening on the left is that we're getting really, really big positive outputs. So the left and the right are both approaching positive infinity. Therefore, the limit on the left is positive infinity, approaching positive infinity, and the limit on the right is approaching positive infinity. Therefore, the limit as x approaches 6 of 17 over x minus 6 quantity squared is equal to positive infinity. Now, we might say, okay, what's different about D? I'm going to do D in a different video because it's got an absolute value, but E is pretty similar. E is pretty similar. I'm going to show you. We need to fix this. We've got fractions within a fraction. So I'm going to multiply both the numerator and the denominator by 2x. And when you multiply by the same value in the numerator as you do in the denominator, you're really multiplying by a factor of 1. So you're not changing the value, you're just changing what your expression looks like. And the reason for this is because we have a complex fraction. That's a fraction within a fraction. So when I multiply 1 over x times 2x, I'm going to get 2. And when I multiply 1/2 times 2x, I'm going to get x. And then in the denominator, I've got 2x times x minus 2. And I want to find the limit as x approaches 2. Well, look at this. 2 minus x over x minus 2. 2 minus x over x minus 2 is equal to -1. It's almost the same thing over itself. And this is kind of a rule that you may have been shown, a minus b over b minus a is always equal to -1. Always equal to -1. And I'll show you why. So I'm going to show you why with this one. I'm going to factor out a negative from the numerator. Actually, first, I'm going to reorganize it because I think that you'll really see it this way. So I'm going to reorganize it so that the x terms are first. So this numerator is the same. Have not done anything yet. I've not done anything. I just reversed the order in which I'm adding them. So now I've got the opposite of x minus 2 over x minus 2. So now I factor out a negative. And now x minus 2 over x minus 2 is 1, and I have on the left-hand side -1. So this is the same thing as -1. So I'm now going to be able to rewrite this as the limit as x approaches 2 of -1 over 2x. Once I simplify it, I can try direct substitution. And if direct substitution works, then we don't have to worry about the limit from the left and the limit from the right. I'm going to put that 2 in there, and look at that, -1/4. That's beauty, art, right there, okay? In the last video that I do regarding limits for this review, I'm going to come back and do this problem right here.